All right, this is Algebra 2, Lesson 5, word problems and fractional parts of a number. Okay, word problems that contain one statement of equality can usually be solved by writing one equation and using one unknown. That's a variable. That's what one unknown is. When a word problem contains two statements of equality, they can usually be solved by writing two equations and using two unknowns. Three statements, three equations, and three unknowns, and so on. So in general, to obtain a unique solution, the number of equations must be equal to or exceed the number of unknowns. If the number of equations exceeds the number of unknowns, at least one of the equations is redundant. So we will begin with a problem that can be solved by writing one equation and one unknown. If the equation tells us how much two quantities differ, then one of the quantities must be increased or decreased as required so that the statement of equality can be written. All right, so let's look at example 5.1. Twice a number is decreased by 7. Okay, we're going to write this exactly the way it says. So twice a number, so 2n, is decreased by 7. Okay, that means we're subtracting 7 from it. Okay, and this quantity is multiplied by 3. So we're going to put the entire quantity in parentheses and we're going to multiply it times 3. The result, that means equals, is 9 less than 10 times the number. I like to go ahead and put the subtraction at the end so it doesn't get confusing. So I'm going to put is 9 less, and then 10 times the number is 10 times whatever n is. Okay. All right, so I'm going to distribute 6n minus 21 equals 10n minus 9. I'm going to follow the rules that I have for solving an equation. We've already done the parentheses. I'm going to move the variables to one side. So minus 10n, so minus 4n. And then I'm going to move everything that's a constant to one side. So I've got negative 4n equals 21 minus 9, which is 12. And that's a positive 12. Okay, then I'm going to divide both sides by that coefficient of n. And n is going to equal a negative 3. Okay, now let's look at that same kind of problem, but in a word problem. So 5.2. All right, the number of ducks in a pond was doubled when the new flock landed. So this is twice the number of ducks, right? So we're going to do 2, and then we're going to use number, and we're going to just make a subscript of D so we can tell that this means ducks, all right? When the new flock landed. Then 7 more ducks came. So that means we added 7 ducks. We're going to put 7 there. The resulting number of ducks, that means that equals, was 13 less, so minus 13, than 3 times the original number of ducks, ND. Okay, so all we have to do is use our order of solving equations. So I'm going to move all the variables to one side. So I'm going to subtract ND from both sides. Gives me a negative ND plus 7 equals negative 13. And then I'm going to subtract my constants from both sides so that I can, oops, I made that not a subscript. Okay, so 7, this should be negative 20. And then I'm going to divide both of these sides by negative 1. Get rid of that coefficient of negative 1. So the number of ducks is 20. All right, let's look at 5.3. The sum of -7 and 6 times a number is multiplied by 5. Okay, so we're going to multiply that by 5. The result is 332 less minus 332 than 3 times the number, so 3n. Okay, I'm going to distribute. So 5 times 7 is -30. 5 times -7 is -35 plus 30n equals 3n minus 332. Bring the variable to one side. It's going to be 27n. Going to add 35 to both sides so I can get the constants on one side. Divide by the coefficient. And the number is a -11. Okay, moving on to 5b. This is on page 40, fractional parts of a number. So when we multiply a number by a fraction, we say that we've taken a fractional part of the number. For instance, if we multiply 3/8 by 40, we're going to get 15, right? So 3/8 times 40, this will cancel 5. 5 times 3 is 15, okay? So if you look at example 5.4, 1/5 of the clowns had red noses. If 30 clowns had red noses, how many clowns were there in all? Okay, so this is a word problem that is based on a fractional part of a number. So we had 1/5 of the clowns had red noses. So 1/5 of the clowns and it says had red noses. And if 30 clowns had red noses, how many clowns were there in all? So 1/5 of the clowns is 30. So this means 1/5 times what number equals 30? Because we don't know how many clowns there are. So if we multiply this, that means that we're going to be multiplying 1/5 times Wn equals 30. So we're going to be multiplying by the reciprocal. What number is going to be 150? Okay, let's look at 5.5. 7/8 of the Tartar horde rode horses. If 140,000 were in the horde, how many did not ride horses? Okay, so 7/5 rode horses. 140,000 were in the horde. Okay, if 140,000 were in the horde, how many did not ride horses? Well, it's asking for how many did not ride horses. So that does not refer to the 7/5, right? I'm sorry, not 7/5, 7/8. Excuse me, I read that wrong. So if 7/8 rode horses, that means that 1/8 did not. So that's the one we're going to have to use for our equation because that's what it's asking for in the problem. So we're going to do 1/8 times the 140 total equals the number that did not ride horses. So 8 goes into 140,000, 17,500, the number that did not ride horses. Okay. All right. I'm going to pause here and I want you to go ahead and work the practice problems. And then you can come back and look and see if you got the correct answer.
Houston, we have a problem.
Okay. Check your answer and see if that's right. And let me know if you have any questions. Thanks.